All right, welcome to Start Class. Hope your college hopping is going well, and be ready to report in with all the secret information you've gained. All right, and also bring your spy name when you come. All right, we ended up yesterday with a two-way table talk, and I forget what it was. Was it the hearts and all that? Did we have that two-way table already drawn for the for hearts? Okay. Did it look like this? I'll try yellow. It'll probably show up better. Let's see. Heart and not a heart. What was it? Face and not a face?
Yep.
All right. What were our numbers? I don't have them right here. MK, what's this one?
3,
Then?
10, 9, 30.
All right. So I'll put in the totals in case we need them. It's sort of a knee-jerk reaction whether you need them or not. All right. So we were looking at that and asking ourselves some questions. I ended up with this question, didn't I? I said, what is the probability of being a face or, so we're not using the baby language, or a heart? Is that right? Was that where I ended when the bell rang? Did anyone get that down?
Yeah.
All right, so I'm at the same spot as you. All right, I'm going to talk about that, and I also want to talk about it from a two-way table as well. Have we looked at a two-way table with that yet?
No.
Okay, we just started with this. All right, what's the probability of being a face, and this is symbol union, or we can read it or face or a heart. So here is the point. When you have a two-way table, we're going to go in and first look at face. So how many face cards, Brian, do we have that we can count? Oh, sorry, 12, sorry. So we're getting 12 out of this, and you may be tempted to add that to the hearts, because there are 13 hearts. But look, you already counted this whole row to get the females, and you already counted this block. So when you go and try to count the hearts, you can't double count these. So it's the same problem with our Venn diagrams. So with that then, what number should I grab from this row, MK?
10.
The 10 only. Do you see why I did not grab the 13? So that when you use a two-way table and you're counting like that for a probability number in your numerator, you can't double count anything. So that happens sometimes with this or symbol. So we ended up with what, 22 out of 52. All right, are you happy with that? It's about 42%. There it is, 42%. So let's also look at it in light of the formula. The formula that I want to see, this was like reasoning it through, but there is a formula, and we said the probability of A or B was not just the probability of A plus B. What was the N part? Do you remember MM? Because if we
Minus a or.
Not or, this is or. So this is where...
Sorry.
This is where we have the overlap that we have to subtract. So that means we double counted in this, and we have to adjust for it here. So let's see if that works with this example. A being, say, a heart, and B being a face. So plugging in the formula, probability of heart plus probability of face minus the probability of face and a heart. So I'm doing the same problem again with the formula. I prefer when it's small that you do without the formula, you just think it through, but let's see if the formula does work. So MK, what's the probability of getting a heart?
12.
Out of, right. And what's the probability of getting a face, MK?
13 out of 50.
Right. Just 13 out of 52. And minus, MK, what's the probability of getting both face and heart?
3 out of 50.
All right, does that come out to 22?
Yep.
Does 12 plus 23 minus 3 give us the 22? All right, so if you don't want to, if you have fear that you might forget and double count to that block, the formula will always get you to the same spot. All right, so that was where we were trying to say that as the bell was ringing yesterday. All right, so before we leave that day's work, on the back, is there a check your understanding?
No.
Is there one on the back? What's on the back? Turn yours over. No, that's it. All right, that's all right then. I think we're pretty good on those, and I'll check your homework and see how strong they were on these concepts. Any questions about charts and Venn diagrams? We're going to go on from there. All right, the next thing we're going to talk about is day 5. And MD, I apologize, I gave you day 6. Couldn't you have noticed? All right. So you get to take notes on a piece of paper and put them on day 5 when you return, or staple them next to it or whatever. Can you show her your paper? We're going to take these thoughts a bit further, and we're going to look at something called conditional probabilities. We'll see how far we get on day 5. And I think there's only a day 5 and day 6 left, so we'll see. We won't rush it.
Yeah, let's not test next week.
Well, we're trying to.
Wait, really? Because then I'm gonna miss it.
And we're trying to, what didn't we say? Did we say in here?
We didn't.
We didn't? Alright, so if I finish day 5, say, between now and the beginning of Monday, day 6 is, I might even get into day 6 today. So I'll know more by the end of today, but that's all there is left. So we should test. What day you go on? Thursday and Friday? It's probably when we'll hit the test.
I know. You could give it to me and I
You
could
just
take it home.
Yeah, that'd be fine.
Okay.
All right.
Wait, whoa.
And MD's gone Friday, is that right?
Yeah.
Okay. All right. All right, on this day 5 paper, I did write the homework in my purple ink there. And did MD see it
Yeah.
clearly?
Yeah, I'll
So
show
the
her
homework
again.
part? All right. Let's look at what's called conditional probability. And we'll see what that means. We'll have to define it and then use it. It's actually math today.
Wow.
This whole section has some math in it.
I was gonna say, every time you use the word conditional, we do math, so.
Yeah. All right. It's going to be similar to we had conditional, what was it, probabilities? What was it?
Distribution.
What?
Distribution.
Yeah, conditional distributions.
No.
But you'll get it this time.
Really?
All right.
Will I really?
What I need for you to understand is a new symbol. So we even get a new symbol today. So if you flip a coin and you get heads, and say you flip it again, and you are going to see what the next flip is, there's a way that we can talk about that, and it works like this. What is the probability of getting a heads given a tails? So how many flips have I just discussed?
Wait.
What is the probability of getting heads given tails? How many flips is that describing?
2.
2. So it's written in a special way, and it's written like this. What's the probability of heads given? And the symbol for heads is a vertical line. And it's a little bit longer than the H, but very similar in height. So that is written, the probability of getting heads given it's a tail. So have a new symbol and it's red given. Probability of heads given tails. So we've discussed this already. What is the probability of heads given that you just flipped a tails?
50.
0.5 because 1/2
Doesn't
because
matter.
it doesn't matter. They're not. The coin has no memory, sort of like me. So
Aw.
we go ahead with that, and we
That's so
will
true.
see. Oh yeah, and make sure you have the old hag setting off of the camera. Every time I look
Wait.
at the camera, said they got the old hag setting on again.
Oh.
Dang,
Alright.
that's rough. Who says that?
I
God.
remember you saying that last
You
year.
worked too hard on yourself.
Yeah, Miss Howe, seriously.
It looks awful. You know, you see yourself, picture
Oh.
yourself.
Oh, I
Yeah.
get that, yeah.
Everybody thinks, oh, that
Everyone
looks
thinks everyone's
terrible.
looking
All right.
No, but
I
you
have
do
this
have a
vision
good
of
memory.
myself of being 18 and it doesn't come through
Aw.
in the video. You
No,
know?
but Miss Powell, you have a good memory. You said you didn't have a good memory. Like, you literally have, like, a really good
Teachers
memory.
I couldn't even remember what was the word. I forgot. That MD remembered. Resist it. I
Well,
can't
none of us
even
can remember
that.
No, but, like, you
I don't
remember
think
little
people look
things.
that
Like,
up.
I'll tell you, like, my brother's birthday is on Saturday, and, like, you'll remember that. I'm like,
Okay.
whoa.
All right. Onward. So, what do you think this means? Read it to me. MM. We have a new symbol. Let's see if you can read it to me.
The probability of tails given heads.
All right, given is the new word of the day. Given. So, what is that probability? Once again,
50.
coin has no memory, so we go ahead and realize that no matter what has gone before it, no matter what given in this scenario, we're going to have the same probability as if it wasn't given. So, in fact, we can make a statement of that, and it is like this. The probability of tails given heads is the same as the probability of just tails. So that's telling you that given heads part didn't make a hoot of difference. Can it work the other way? The probability of heads given tails is the same as just the probability of heads. So this did not matter at all, that we previously had flipped the tails in this case and a heads in that case. When that happens, those events are very special. And so we will actually make a statement about that in general. When you have the probability of some event A given some other event B, and it's exactly the same as probability of A, so that given B part didn't matter at all. And the other way is also true. B given A is the same as the probability of B. We call that, we give that a special name, that case, and that's called, and it'll make perfect sense when you hear it, independent events. One does not depend on the other. It doesn't affect it at all.
Isn't that, like, mutually exclusive and all that? How come
Right.
that's different?
Similar. So this is called independent events, and not all events we're going to study are independent, but I started out with the coin flip, which is independent. One flip is independent of the next. So let's take it a step further. Baby steps only in here. Let's do one where it is the probability of A given B is not the same as probability of A. So we will not have independent events. All right, to do that, we will look at, first of all, let's define conditional probability in words, and then we'll do an example. Conditional probability is the probability of an event given another event has occurred. So, probability of an event given another event has occurred.